In this video, we'll be looking at calculating the probabilities of dependent events rather than independent. We have a similar formula for this one, which just says the probability of event A happening and event B happening is equal to the probability of event A happening times the probability of event B given event A. Now I'll say that again, this last part is read as the probability of B given A. And what that means is, what are the chances that B happens if we already know that A has happened? Let's look at our first example. We roll two six-sided dice. Determine the probability that the first die shows a 2 and the sum of both dice is less than 5. Well, we can figure out that these are dependent events because what I roll on the first dice is definitely going to affect my chances of the total being less than 5. So we can fill in our formula. Probability that we get 2 and that the sum is less than 5 is going to be equal to the probability that I get a 2 times the probability that my sum is less than 5 given I already rolled a 2. The first probability is pretty easy to figure out. It's just one way to succeed, right? Roll a 2 out of 6 total options. The second probability is going to take a little bit of thinking to find the answer for. So once we know that we've rolled a 2, let's consider our options. We have 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, and 2 and 6. So we have 6 total possibilities. Out of all of these, this one has a sum less than 5, so does this. 2 plus 3 is exactly 5, though, which is not less than 5. So we now only have, out of these 6 total options, 2 that are successes. Because we can come back over here and say, well, my probability that the sum is less than 5, once I already know I rolled a 2, is just 2 out of 6. Simplify this and do your multiplication out, and you get 2 out of 36, or 1 out of 18. Second example, a box contains 6 red marbles and 4 green marbles. Determine the probability of picking 3 green marbles in a row without replacement. So there's that without replacement that tips us off that this is probably going to be dependent. And we can confirm that because once I've picked the first green marble, that's going to change my chances of getting another one because I'm not putting it back in. So if we kind of break this down, the formula is going to look a little funny. Probability of getting 3 greens is going to be the probability of getting a green times the probability of getting a green if I've already gotten a green times the probability of getting a green if I've already gotten 2 greens. Don't worry too much about this notation. If you can make sense of the algebra behind it, that's much more important. So probability of getting a green marble, at first, there are 4 green marbles out of 10 total marbles. Now, once I've gotten 1 green marble, there's now only 3 left in the box, and now there are only 9 total. So my fraction changes here, right? My probability changes to be 3 green out of 9 total. And then once I've picked that one, there's now only 2 green left out of 8 marbles total, which gives us a 2 out of 8 probability for that last probability. And then once you multiply these all together and simplify your fraction, it should come out as 1/30th.